Hey, what's up? It's your old pal, Mr. Cook. We're going to go through the last couple problems from this conics review. So I guess it's all graphing now. This is the fun stuff, right? Okay, so identify the center and the radius. Well, I'm guessing that means this is a circle. Yeah. Identify the vertex, focus, and directrix. Well, you only have a directrix if it's a parabola, so that's got to be a parabola. Identify the center, vertices, and co-vertices and the foci. Well, I mean, you only have those things if you have an ellipse, so that's probably going to be an ellipse. And then the vertices, foci, and asymptotes. Excuse me, gosh, I've been talking too long. Need a little water there, sorry. Okay, so you only have asymptotes if you have a hyperbola. All right, so identify the center and the radius and then sketch the graph. Yeah, so for this one, what you would want to do, I guess technically for all of these, is just remember how to complete the square. So completing the square is just like it's kind of a, I think it's not a bad process. It's pretty easy. If you can do it once, you can usually do it like multiple times. So I don't know. I'll just show you how to do that with the first one, and hopefully by the last couple, you'll have the process down pat. All right, so with number 19, I've got an x squared and a y squared. So that means I need to complete the square with x and also with y. So what I do is I usually group them together. So wherever I have an x, here and here, I'll group those together. So I'll have an x squared and another x, 8x. Then I'll group the y's together. So I've got a y squared and a 2y. And then usually if I have any constants, I just move those over to the other side. So I'd subtract 9 from both sides, so equals -9. Okay, so now what I'm going to do is create a perfect square with the x part and with the y part. So here's how you do it. If you have a lead coefficient, like with x, it's just 1, right, with x squared. So if I did have a lead coefficient other than 1, I would like factor that out. But I don't have that, so I don't have to worry about it. But if I did, right, like I'd also factor it out of like that 8 right over there, okay? But since I don't have to factor anything out, any lead coefficients, what I do is I just take this thing here, right? And I want to turn it into a perfect square. And in a perfect square, what happens is you get like this really neat little property that whatever your coefficient is and whatever your constant is, right, those numbers get multiplied together and then multiplied by 2 in a perfect square. And in a perfect square, it's, well, maybe I should start like this. Yeah. So if I had a perfect square, ax plus b, if I squared this thing, it would be ax plus b times, oh my gosh, times ax plus b. And if I FOIL this out, I would get a squared times x squared, ax times ax. And then ax times b would be a times b times x. And then another b times ax, which would be a times bx. And then b times b, which would be b squared. So what happens is this middle term becomes a 2ab, right? And that means that like the middle term, I need to divide by 2 to figure out a and b are going to be. So like all that is just, showing you why I'm doing this next step. But you don't have to know all that stuff to actually complete the square. All you need to do is just go to the term that has just the x or the y and divide that number by 2. Okay, just remember that part of it. So if I divide 8 by 2, I get 4, positive 4. So that means that my perfect square is going to look like this: x plus 4 and then squared. Okay, I just took this number and divided by 2. Okay, and that's how I got this, positive 4. You also need to account for the sign that's on it. So if it's like a -8, it'd be -4. But since it's positive 8, it's going to be positive 4. Okay, now you do the same thing with the y's. Divide that 2 by 2. 2 divided by 2 is 1, so I get y plus 1 squared. And then, now remember, this is all just procedurally, okay? I'm not going to go through a ton of explanations and stuff, but procedurally, that's what you do. And then, because this is not the exact same as this, there's like this added term, you add a number over here, and that's going to be that 4 that you have here. 4 squared. Add that on the right-hand side. And do the same thing with this. We're adding on a 1 squared over here, okay? And then that's when we put the rest of the thing together. So it's going to be x plus 4 squared plus y plus 1 squared equals 4 squared 16. 16 and 1 is 17. 17 minus 9 is 8. Okay, so equals 8. So that means that our center is going to be located at, if you look at the equation for a circle, y minus h squared plus x minus h squared minus plus y minus k squared equals the radius squared. That means that h is equal to 4, negative 4, and then that k is equal to negative 1. So that means that our center is located at negative 4, negative 1, and our radius is going to be equal to, let's see, radius squared is equal to 8. So r is equal to square root of 8. And that's like about 2.8, 2.7 or something like that. Okay, so now let's graph this thing out. So the center is located at negative 4, negative 1. So here's our center right there. And then the radius, square root of 8. Let me do it exactly on my calculator and see what we get. Square root of 8. It's like 2.83. So I'm going to go to the left, to the right, up and down by 2.83. I'm going to do my best to approximate that. To the right by 2.83, to the left by 2.83, up by 2.83, and then down by 2.83 right there. Okay, and then we just connect the dots and make your best circle that you can. There you go. All right, there's my graph. Center and radius. All right, that's everything that they asked for. All right, now I'm going to give myself a little bit more room to write for the other stuff. All right, so this is going to be, looks like a parabola. And I know it's going to be a parabola because I only have a y squared and no x squared. Remember the 3 questions, right? Okay, so let's write this up. I guess, well, let's see. How much of this do we need to know? We need to know the vertex, the focus, and the directrix. Man, that's a lot of stuff. Oh, well, whatever. So let's get this thing into standard form. So to get it into standard form, we're again going to complete the square. So we just need to group the y stuff together. So y squared minus 10y. And then we're going to move all the other stuff to the other side, okay? So we're going to have, it looks like a negative x and a negative 21. All right, let's complete the square with the y stuff. Okay, so let's see here. I'm going to take this. I take the term that's on the y and I divide this thing by 2. So y, and then negative 10 divided by 2 is a negative 5. So y minus 5 squared. And then I need to add a term onto this side, and that's going to be that negative 5, but squared. Okay, so negative 5 squared. So here's what I've got so far. I've got y minus 5 squared equals negative x, and then negative 21 plus 25 gives me a positive 4. And then remember what the standard form for a parabola looks like. It's y minus k squared is equal to 4 times p times parentheses x minus h. So all we need to do is just like get x by itself. So we'd like, divide out a negative 1. So that's all we need to do is just factor out a negative 1 from this. So that would get us the following. We'd get negative and then x minus 4 equals, and then it's going to be y minus 5 squared. Okay, so we can basically get all the information that we need from this. Our vertex is the h, it's the h and the k value. So what does that look like from this? The h looks like it's 4, right? And then the k looks like it is 5. So 4 comma 5. So let's graph that out. Over 4 up 5. There's our vertex. Okay, and then the p value. Okay, so that's kind of weird because 4p is like just negative 1. Negative 1 that's like out front there, right? So negative 1 equals 4p. Okay, and that means that p is going to be equal to negative 1 over 4. So next, we know that the parabola, because the y is squared here, it's either going to open to the left or to the right. And then since we have a negative p value, it's going to be the one that opens over to the left. Okay, so we're going to have a parabola that like looks something like this. We just got to get a couple coordinates from it and stuff. So one coordinate we can get is something that we need, the focus. So the focus is going to be negative 1/4 inside of that parabola. So we're going to go to the left by 1/4. So if this coordinate is located over here at 4, 5, that means that the focus is going to be to the left by negative 1, well, to the left by 1/4. So we're going to subtract away 1/4 from our x value. So 4 minus 1/4 would give us, let's see, that's 16 over 4 minus 1/4, so that's 15/4. So that means that our focus is going to be located at 15 over 4, comma, 5, which would be like, let's see, that's 3.755. So it'd be like right there. There's the focus. And then the directrix is going to be the opposite direction. So if we have that 1/4, now we're going to add 1/4 onto the x value. So the directrix, it's going to be like a vertical line because it's like behind the parabola. So x is equal to, and then it's going to be the x value plus 1/4. So 4 plus 1/4, which I believe that's, let's see, that's 16/4 plus 1/4, so 17/4. So x equals 17 over 4. There's the directrix. And then I don't know what they would want for the rest of the graph. Maybe just plug in a couple coordinates or something like that. Yeah, let's like plug in a few, I guess. All right, so, well, let's graph that out, the directrix, 17/4. So that's 17/4 is 4.25. So if I go over 4.25, and then it's just a vertical line, so it looks like that. There's my directrix. Not a lot of room to write in this graph, but whatever. Okay, let's get a couple coordinates for the parabola. So maybe we'd want to plug in, I don't know, let's plug in some y values, like, let's see, we already plugged in 5 to get the vertex. So maybe we plug in like 6 for y, and then use the axis of symmetry to graph the rest of it. So if I plug in 6 to my equation, where is it? Right over here. Let's find the corresponding x value for that one. Okay. So it'd be 6 minus 5 squared equals negative x minus 4. So 6 minus 5 squared is 1. If I distribute the negative, I get a negative x plus 4. If I subtract 4 from both sides, I get negative 3 equals negative x. So that means that one of my coordinates is going to be 6 for the y value and 3 for the x value. So 3, 6. So go over 3 and then up 6. There's another coordinate on my vertex. And then from the axis of symmetry, which will be like it'll be a horizontal line that passes through the vertex. Another coordinate would be like right over there. And, you can just keep going from there. But that's probably usually like good enough if you just have like a couple coordinates, like 3 of them. I don't know how many your teacher wants. If you want 5 coordinates or whatever, just keep plugging in more y values, like 7 and 8 or something like that. Okay, so that's it for number, whatever that was, 20, parabola. Now let's do 21 and 22. So this is going to be an ellipse and then also a hyperbola. So for the ellipse, you can just, again, complete the square and figure out what the ellipse looks like. Ellipses and hyperbola are, it's really weird. Parabolas, I think, are the toughest ones to graph because especially if you have a smaller graph like that, the shape can blow up really quickly. And there's not a lot of room to like kind of write and make sense of all of the coordinates. But with ellipses and hyperbolas, it's a little bit easier, especially the ellipse. All right, so let's do the ellipse. Looks like we just need the center and then the vertices, co-vertices, and foci. That's actually like not bad. So first we got to complete the square and find it in standard form, and then graph all that additional stuff. So just like before, we'll group together the x's. So we've got 4x to the second power plus 16x. And then with the y's, we've got y squared and minus 6y. And just like before, we're going to move any constants like that 9. We'll move it to the other side. So equals negative 9. Okay, so we're going to complete the square for the x's and the y's. For the x's, there's one additional step that we didn't have to do previously, and that's get rid of the coefficient that's out front. So we're going to factor out the 4. So we've got 4x squared plus 4x now. There's no coefficient there, so that's still y squared minus 6y. Now complete the square, on the x's. So we've got 4 and then parentheses, and then it's going to be that 4 we're going to divide by 2, so x plus 2 squared. And then take this negative 6, divide that by 2, we get negative 3, so y minus 3 squared. And then we're going to add those constants again, so we have a 2 squared and a negative 3 squared. And there's one additional thing that we got to worry about, and that's that 4 that's over here. So just like once you do the 2 squared, also multiply that by 4, okay? Whatever, coefficient that you have out front, that also needs to make an appearance over here, okay? All right. So with that being said, let's see what the ellipse looks like so far. So we got 4, and then x plus 2 squared plus y minus 3 squared equals, and then let's see what we've got. 2 squared is 4. 4 times 4 is 16. Negative 3 squared is 9. So 9 minus 9 and then plus 16 gives us 16. And it doesn't quite look like an ellipse yet. Do you remember what the ellipse is equal to always? It's always equal to 1. So we got to turn that 16 into a 1. And to do that, we got to divide both sides by 16. And that'll make it look exactly like an ellipse formula. And we can graph this thing out really, really easily. So, the 16 and the 4 cancel out. So we've got x plus 2 squared over 4 now. And then there's nothing to cancel out with that 16, so it just is what it is. Y minus 3 squared over 16 equals 1. Okay, so now let's graph out the ellipse. This should be pretty easy. And then we'll find all the little odds and ends, okay? So the center is going to be located at negative 2, positive 3. So negative 2 up 3, there it is, the center. And then remember that it's always a squared and b squared, right? So a is how far to the left and to the right the vertices go from the center. So if a squared is 4, that means that a is equal to 2. So I'm going to go to the right by 2 and to the left by 2 from the center. So that also gives me the location of 2 of my vertices. One of them is going to be over at 0, 3. And looks like the other one's going to be over here at negative 4, 3. And then if 16 is equal to b squared, then that means that b is equal to 4. So that means that, since I'm dealing with the y radius, it's going to go up and down by 4. So go up by 4, 1, 2, 3, 4. And that puts us at negative 2, 7. And then go down by 4, 1, 2, 3, 4. So it looks like that's going to be at negative 2, negative 1. And then, draw the rest of the ellipse in. So just connect all of the little vertices, make it look as much like an ellipse as you can. Ugh, that's terrible looking. But whatever, close enough. All right, now we're going to draw in the foci. Remember that the foci go along the major axis of an ellipse. So it's going to go along this line right over here. It's going to be some coordinate that is c away from the vertex. I'm sorry, from the center. So the c value is found from this equation. It's going to be c squared is equal to b squared minus a squared. And that's just you just take the larger of the two and then the smaller of the two. Just make it positive. So it would be 16 minus 4 equals c squared. 16 minus 4 is 12. And c squared, so that means that c is equal to the square root of 12. Which is roughly I think it's 3 point something, 3.4, 3.5. Let me see what it is on my calculator. Square root of 12, 3.46, or about 3.5-ish. So from the center, I need to go up and down along the major axis by 3.46. So go up by 3.46. There's one focus. And then down by 3.46, 3.46 would be right there. And those coordinates are located at, let's see, it's going to be negative 2. And then remember that the center is located at negative 2, comma 3. So I'm going to do 3 plus square root of 12. That's up by square root of 12. And then this one's going to be located at negative 2, comma 3 minus square root of 12. So I go up and down from the center by that amount, square root of 12. Okay, so there's the ellipse. It's much more procedural than the parabola stuff. It's the same stuff every time. If you do 2 or 3 of these, it's the same process. Okay, now the last one, the hyperbola. Hyperbolas are usually pretty easy too, especially if they're just asking for the foci and the asymptotes. It's usually pretty easy. All right, so First, we complete the square to make this thing look nice, get the equation out of it. So we group the x's together, 9x squared. Oh, there's no other x's, okay. And then the y values are going to be a minus 25y squared. Come on, y squared, there we go, minus 100y. And then I'll move the other thing to the other side, so 325. Okay. So whenever I just have like an x squared or a y squared, that's it. Right? That means that that technically the x component or the y component, whatever you got, part of the center is going to be 0, because I can factor this to look like this: 9 and then x minus 0 squared, right? Because what is x minus 0? X minus 0 is, it's just x, right? So that's how I can get that. And the rest of it, I got to complete the square. So I got to factor out a negative 25 from the y part. So if I factor out the negative 25, I get y squared minus, wait, actually, since I took out a negative, the negative comes out of that also. So it's actually plus 4y. There we go. Equals 325. Excuse me. And then let's complete the square on this part. So that's already done. 9x minus 0 squared minus, and then it's 25. And then if I divide that positive 4 by 2, I get y plus 2 squared equals 325. But then I've got to take that 2 squared, right? And then I got to multiply by the number that's out front, which is negative 25. Okay, so here's what I've got. I've got 9, and then x minus 0 squared minus 25, and then y plus 2 squared equals, and then that's 325 minus 25 times 4, so minus 100. That would give us 225. All right, and then I divide both sides by 225 to get that 1 that I want, right? So it's 9x minus 0 squared over 225. And then plus, minus, darn it, minus. And then it's going to be 25y plus 2 squared over 225 equals 1 now. Okay, and then I simplify. So 9 divided by, or 225 divided by 9 is going to be 25. So I'd get x minus 0 squared over 25 minus, and then 25, or 225 divided by 25 is 9. So I'd get y plus 2 squared over 9 equals 1. Okay. So there's my equation. I'm going to erase all this stuff so I have some room to draw and write and all that stuff. But that's my standard form equation for the hyperbola. That's what I need. All right, so let's get the center of the hyperbola. The center of hyperbola is going to be 0 and negative 2. And I also kind of know what this graph is going to look like, because if the x squared part is positive, that means it's going to open to the left and to the right. So what I'm going to do is find the vertices first. And the way that I find the vertices is by getting like that, that a squared term, from there. And I find a. A's difference is going to be from the center to the vertex. So it looks like a is going to be equal to 5. So I go to the right by 5. 1, 2, 3, 4, 5. There's one vertex. That's located at, 5, negative 2. One vertex. And then the other vertex, I go to the left by 5. So 1, 2, 3, 4, 5. So that other one's going to be located at negative 5, negative 2 for the other vertex. Okay, and then let's see, what else do they want? So those are the vertices, the foci. So the foci are going to be inside of the hyperbola. So remember, hyperbolas are going to open to the left and to the right. So the foci are going to be like somewhere in this region over here. So let's figure out where they're going to be. So what I do is I take the the a squared and the b squared, so 25 and 9. I add them together, and that's going to give me some value c squared. And c is how far away the the foci are from the center. So if I add them up, 25 and 9, that gives me 34. And that means that c is going to be equal to the square root of 34, which is like real close to 6. It's like 5 point something. Let's see what it is on my calculator. Square root of 34, 5.83. Okay, so 5.83. So from the center, I'm going to go to the left and to the right by 5.83. So if I go to the right by 5.83, I go over 5 and then close to 6. So like right over there, there's one focus. And then if I go to the left by 5.83, more than 5, almost to 6. So it's like right over there. And so that means that the foci are going to be located at the following locations. One of them is going to be at, let's see, so the x direction, it goes over square root of 34. So square root of 34, comma, -2 is the y value for it. And then the other one's going to go to the left by the square root of 34, which is negative square root of 34, and then comma -2. So those are my two foci. I got those. Now for the asymptotes of the, the slopes of the asymptotes, really want the equations of the asymptotes. I think they might want the equations of the asymptotes, and that's fine. Whatever, I can do those too. So like the slope of the asymptotes is always going to be equal to the plus or minus b over a. So the b value, comes from the y part. So if 9 is equal to b squared, that means that b is equal to 3. And remember, my a value is equal to 5, right? So that means that my slopes are going to be plus or minus b over a, so 3 over 5. And if you need to write out an equation for the asymptotes, the easiest way to do that is using like the cheapest of all of the linear equations, which is slope intercept or point slope form. Point slope form goes like this. It's y minus y1 is equal to the slope m times parentheses x minus x1. And you already know the slopes. One of the slopes is going to be 3/4 or 3/5. The other one is going to be negative 3/5. And then the other coordinate, that you use the x and the y, that's going to be like the center, which is, that we found with the center is 0, -2. So just plug those values in and you've got your equations. Y minus -2 equals the slope, which is either a positive or a negative 3/5. And then times x minus x1, and x is going to be the x value for the center, which is 0. And, you can make it look a little bit nicer. So y plus 2, there we go. There are the equations for the asymptotes. And then sketch the graph. So the graph, you just follow those slopes, 3/5. So remember that slope is rise over run. So from the center, you go, rise 3, so up 3, 1, 2, 3, then run 5, 1, 2, 3, 4, 5. So if you just follow that with a dotted line, that's drawing out your asymptotes. And then, the other direction is going to be going over to the left by 5 and then down 3, 1, 2, 3. So it's like that. So there's your asymptote that has a slope that's positive 3/5. And then negative 3/5 means you drop down 3, 1, 2, 3, and then to the right 5, 1, 2, 3, 4, 5. So here's the other one. And then up 3, 1, 2, 3, and then to the left 5, 1, 2, 3, 4, 5. All right, there's my asymptotes. So just, use your vertices and then follow the asymptotes. And there's your hyperbola. Going to the left and also going to the right. All right, so there we go. That's everything that you could need for this review. I know I only went over one example for each of them, but, that's just how the review goes. Okay, that's it for me. I'll probably start trying to do the extra practice problems, but that's it for this review. Okay, see you then. Bye-bye.